Hey, congratulations on finding this video. You've done it. So good job. I am hoping to make this video at least as entertaining as possible, just to help yourself feel good. Give yourself a high five for watching this video. Today, what we are going to be doing is going over simplifying radicals. Quick little announcements. Please make sure that you watch this video so that you can do the assignment. By doing this assignment, you will get extra credit. When I come back, I'll give you a tech token, plus it's worth double. So there's all sorts of incentives to get it done today. Please pay attention to this video. If it doesn't make sense when it's up here on the screen, you can watch it later on your own. But please make sure that you stay off your phones. Put your phones off and away, deep away until this video is done. And even then, please be working on stuff. Just in case you forget, what you need to work on is this assignment. You need to work on anything you didn't finish other days, including the IXL stuff. So hopefully you get lots of stuff done today, and I'll come back and be like, oh, your grade is so amazing. So that's what we're going for. Okay, so today we are talking about simplifying radicals. It's taking the things that we've done over the past few days and combining them, and then we're also going to do like a big flex on it. The way that I'm going to be doing this video is I'm actually going to do these out of order, even though it says simplifying radicals, then algebraic square roots, and then the other one. We're going to like do the first one first, the last one second, and the other one. Anyway, you'll figure it out. Okay, so we're going to start on simplifying radicals. Now here is the idea. You did these the other day, problems like this the other day, and then we emphasized, I'm just going to re-emphasize what we did, but you're doing it without all the like the little guiding steps. So we need to simplify the square root of 18. I can go through my list of perfect squares and figure out what it equals, because 18 is, and so if we go through the perfect squares, you might need to have those up somewhere to remind you what the perfect squares are. In fact, watch, you can even go like this. You can do perfect squares list, if that helps you. It's also should be on your desk. You can look at the diagonals. Wow, this is having a hard time loading. There we go. So it's those perfect squares. So you're trying to figure out which perfect square, what's the biggest perfect square that goes into there, into 18, and I can see that it would be 9 and 2, right? And then this is what I wanted to show. 9 splits into 3 and 3. And the reason why I'm showing this is because what we learned yesterday was we talked about this being the index. We don't put the 2 there, but that's what it means. What it means specifically for this problem and why we do perfect squares is because for every 2 factors, one of them is going to come out. In other words, we find the square root of 9. So that's going to come out here. And the 2 here is stuck inside. So our final answer would be 3 square roots of 2. And so come in here, type it in, 3 square roots of 2. Yes, that is what I want to answer. So that's what you're doing with the number parts. We did this the other day. In case you need to see another one, let me show you another one. So the square root of 128. And you can, again, get your perfect squares list and start going from those perfect squares and dividing. Another way that you can do it if you are, because you can actually just use a calculator. So I see that it's even. It's an even one. So that means I could use either 4 would probably work, maybe 16, maybe 36. I'm not sure. I'm gonna go and try those. So Delta Math, we have the calculator, scientific calculator. So I'm gonna do 128. I'm gonna try 36 first because it's the biggest one. No, it didn't work. The biggest even one. And then 128 didn't work. So let's try the other ones. 49. Nope. 64. Hey, it did work. So we have 64 and 2, right? I just tried perfect squares. If you're not used to the perfect squares, use the table. It's fine. Totally fine. Then the reason why is because 64 is 8 times 8, which means those pair up, come out. So there's the 8 that would come out. And then the 2 would be stuck inside, no buddies. So a way I think about it is this radical. You can think of this radical as being like jail, and you're trying to break out of jail. And in order to break out, you need a buddy. And then once you break out, you become 1. And then here it is outside the jail. So the radicals like the jail, you need a buddy to break out. You need 2 buddies to break out of jail. That was weird. And then what doesn't have any buddies has to stay inside. So this would be 8 square roots of 2, or 8 root 2 is how we would write it. Say it, 2. 8 root 2. So it's doing those. For the sake of time, I'm going to move on to the next part. This went through and it was showing dividing by each of the square roots, trying to do the biggest one first. Okay, then I'm going to do the last section, the simplifying radicals next. These are related, but weird, right? And I'm showing you this because this is on the SAT. I will show you when I get back problems exactly from the SAT so you know what to expect for doing this. So we're going to do the square root of 13x to the third. So we're going to work these in a very similar way to what we just did. However, now we have x's involved, and notice that it's multiple choice. So first of all, 13. 13 doesn't split into anything. There's no perfect squares that divide into 13. In fact, the only thing that divides into 13 is 1 and 13. So that's just going to have to stay inside. In fact, I could put a box around it. But then x to the third would be x times x times x, right? That's what x to the third means. Then here's the buddies that are going to come out, and this one is stuck inside. So our final answer would have an x on the outside, a 13 on the inside, and the x also on the inside. So our answer would be that one down there, and voila, it is done. Okay. And they get more complicated, right? Because that's what math does. So let's go through this again. So we have the square root of 3x to the 5th. Now, this is a really good one to show you another skill that could make it easier. It could make it more complicated. It will be easier when the numbers get bigger. But for now, let me just show you what you do. So first of all, 3, can't split it into anything. It's just going to stay inside, right? X to the 5th. So here's the one way that you can for sure do. It just sometimes is a lot of writing. So x to the 5th means I'm multiplying x by itself 5 times, right? So I have one set of x's. Here's another set of x's. And then this one is stuck inside. So I had 2 x's that came out. And then one stuck inside. So let me show you. Oh, and then we could multiply them. X, so then we'd have these 2 x's. If I multiplied x multiplied by x, I would get x squared. And then stuck inside would be the 3 and the x. So as far as the answer goes, that's the one I would answer. But let me show you what I could do with these exponents. And if this blows your mind, ignore it and just draw out all the x's. But you're going to get higher powers of x, so this is what's helpful. We're going to take this 5 right here. If I took the 5 and I divided it by 2, I would get 2 with a remainder of 1. You guys remember doing remainders? So this 2 right here became the exponent of what comes out, and the 1 remains inside. So that helps a lot when you're doing these, especially when you get bigger powers, because like sometimes you'll have like x to the 9th and you don't necessarily want to write out all 9 x's, though you could, but it's a nice way to check that you're doing it. So that's just with the powers of x or y, like whatever the variable is, that's what you could do. Okay, so let's submit that answer. Do one more. This is, let's do this. So we have the square root of 3x to the 3rd. So the 3 doesn't have any buddies, so it's going to stay on the inside for sure. And then x to the 3rd, we can do the dividing. Divide it by 2 is 1, remainder 1. So 1x comes out and 1 stays inside. You don't need the ones there. So it's just the one without the ones, like without that, without those exponents. And there you go. And do we have another one that's helpful? Ah, yeah. So here's one where it's really helpful to know that trick, the way of looking at them a different way. So 13, x to the 9th. 13 is going to have to stay inside because nothing else is going to come to the 13. Then I'm going to take this 9. I'm going to divide it by 2. 9 goes into 2 4 times with a remainder of 1. So it's going to be x to the 4 on the outside, and then 1 remains on the inside. Does that kind of make sense? 1 remains on the inside. So it'd be that last one. Do we need to see another one? This is nice. The only thing with this one, I'm just going to do this one right on here. So nothing comes out with the 13. So the 13 for sure has to be on the inside. And then the x squared means one of those x's comes out and nothing is left on the inside. So it'd have to be this one down there. Woo, that one down there. Good. Hopefully this makes sense. Okay, now the next section. It's going to be a big flex. We can do it. So first, I want you to take a nice deep breath and say, I can do hard things, because these get real hard real fast. And especially if you're not fully strong on your division. So let's go in. Oh, this is not too bad. Okay, what do you notice different about this one compared to the other ones? Did you notice? So I'm going to write it down. So while I'm writing it down, what is different compared to the ones that we've already done? Did you notice that there's actually stuff already outside the square root? That means that we're going to have to do stuff with it. So the number parts are going to handle just like we did on the first section. Now the variable parts we're going to handle like we did on the second section I taught. And now there's this one. In fact, I think I might even switch the order of these just so that your brain doesn't pop before you have to do it. So, okay, so let's start with the number parts. I can do that. So 12 is 4 times by 3. And 4 was 2 times by 2. So here's our 2's. So a 2 is going to come out. Makes sense so far? Oh, wait, and the 3 is going to stay inside. So down here, my answer, I know I'm going to have a 3 on the inside and a 2 on the outside. Okay, good. Now let's do the x's. I have x to the 7th. I'm going to come down here and just do 7 divided by 2 is 3 remainder 1. So what's going to come out is an x with the power of 3, and 1 x will remain on the inside. Or if it makes more sense to you to do 7 x's, 1, 2, 3, 4, 5, 6, 7. Here's 1 x, 2 x's, 3 x's, and 1 stays on the inside. Does that make sense? At least one of them. Does one of them make sense? And then for the last one, we have this y to the 4th, and I can just do 4 divided by 2 is 2. But watch this. So we already had, I'm just going to bring this one straight down. So many arrows. If you looked up and looked down, it's going to be confusing. I'm sorry. This y to the 3rd was already out there, right? I mean, squared. It was squared. Just kidding. Squared. Undo. Okay. That squared was already there. So now, if I want 2 more to come out to it, the rules of exponents say I add them. So I'm going to take this 2, so many arrows, I'm sorry, and add to it. So what I would have at the end, final answer, would be 2 x to the 3rd, y to the, and then 2 plus 2 is 4, square root of 3x. Okay, if you need to rewind that and watch it again, you can. You might be able to see it better on the next one, so I'm just going to move on to the next one. So x to the 3rd, y to the, oops, I did not, 3rd, arrow over y to the 4th arrow over square root 3x. Whew, it's always a relief when I get it right. Okay, a lot of steps in there, right? We took a big breath. Let's just kind of go through those steps again, just so that you can see it before we do the next one. We did the number part. That was the red stuff, right? So I split it up 4 times by 3. 4 split up into 2 times 2. So 1, 2 came out and the 3 stayed inside. Okay. The x's. I can either write out all 7 x's, split them up. I see 3 of them come out. 1 stays inside. The y's, I could write them out. 4 y's, and then 2 of them come out. But 2 of those are going to come out, and I could write it like y and y right here, and then just remember to add them all together. Or I can just come and add to the exponent. Ooh, that was a 2, right? And so that's where I got the 4 from. Lots of parts, right? Lots of parts. Okay, let's try it with this one. Let's do next problem. Okay. The square root of 36, x to the 3rd, y to the 7th. So 36, nice news about that is it's 6 times 6, which means that that's going to come out. And I'm going to write it down here because it makes more sense to me. And then x to the 3rd, I'm just going to bring it down here and do 3 divided by 2 is 1 remainder 1. So 1x comes out and 1x stays inside. And then y to the 7th, I'm going to do 7 divided by 2 is 3 remainder 1. So 3 y's will come out and 1 will remain inside. And that's my final answer. That was a lot friendlier, wasn't it? My guess is if you're like most people when they do these, they're going to get something that's crazy hard and you'll be like, this doesn't look a thing like mine. And if that's the case, I apologize on behalf of Delta Math. Okay, square root of x, y. Okay, I'm just going to keep on doing more. If you are done watching the video and you want to just start on the problems, go ahead and start. The rest of this video will likely help you do more problems or be able to understand the concept better. And you can watch it again. Remember, you can rewind. They can go into Google Classroom and watch this, and it should help. Okay, so we're going to we have y square root of 24, x to the 5th, y to the 3rd. Okay, so let's start with the number parts because the number makes the most sense for my brain, at least, to do is the numbers. So 24, let's see, the biggest perfect square that goes into it, I think really is 4 times by 6, and 4 is 2 times 2. We could keep on splitting up 6 and get 2 times by 3, but there's only one pair of 2's, and each of those would have to stay inside, which I might as well have just done 6. So on the outside so far, I have a 2 on the outside, probably an x here, probably a y there, and then 6 on the inside. Does that make sense? So that was the number part. Now I'm going to do the x's. So the x's, I'm going to do 5. How will I do it? Do sideways. 5 divided by 2 is 2 remainder 1. So on the outside, I'll have 2 x's that come out and 1 that remains inside. And then before I do the next part, I forgot. I should have brought this y down that was already there. And the exponent to the y that's already there is 1, even though we don't write it, right? We don't write the 1 because we don't. All right, so now let's do the y. And so I'm going to do 3 divided by 2 is 1 remainder 1. So 1 more is going to be added to the 1 that was on the outside, and then 1 will stay inside. So our final answer will be 2x squared, y squared, square root of 6xy. So 2x squared y squared square root of 6xy. Yes. Okay, again, I'm just going to keep on going because I think it's helpful and I would be lost a little bit. And again, if this makes sense to you, just start doing it, but make sure you're not interrupting other people. So y squared square root of 25 x to the 7th, y to the 7th. Okay, so the number part. 25 is 5 and 5, so they will pair up and one will come out. There's going to be the x part. And then here's the y squared that was already there. And I can add to that exponent. So maybe I'll leave room. And then, yeah, now we're going to keep on doing stuff. So then for both of these, 7 divided by 2 is 3 remainder 1. So for the x's, we have x3 and then 1x remains on the inside. For the y's, I'm going to add 3 to the y's, but then 1 remains on the inside. So my final answer will be 5, x to the 3rd, y to the 5th, square root of xy. Whoa, fancy. Okay, so just type it in. So 5x to the 3rd, y to the 5th. Oh, my 5 didn't make it in front. 5. Square root of xy. Okay, so it's just more of these. Again, if you don't want to watch it, you don't have to keep on watching it. I am going to keep on going just for the sake of another explanation. So we write down the problem. Notice that I can't do these without writing the problem down. And sometimes people are like, oh, I had to write something down. I can't do it. And by the way, do you guys know about sketch.io? You can use the iPad, like your screen, to, if it's a touch screen, to write on it. Up to you. Okay, so there's already a number on the outside. This one's a little bit different. So 9x to the 4th, y to the 6th. Ooh, this one's different in a couple ways. Okay, so the 9, let's see, let's start with the 9. It splits into 3 times by 3, and that will come out. So let's see, that's going to come out, the 3. The 2 was already there. And there's probably going to be something for the x, probably something for the y, and probably something stuck inside, right? So now we're going to do the powers of x. 4 divided by 2 is just 2 with no remainders. So that means just 2 x's come out. So there's nothing, no x's on the inside. And then for the y's, we have 6 divided by 2 is 3. So the y's come out, 3 y's come out. And there's nothing left on the inside. Like, we don't even need that. So my final answer is 3 times 2 is 6, x squared, y to the 3rd. 6 x squared, y to the 3rd. Cool. All right. Hopefully there's enough in here that you can understand the concept and you'll be able to move forward. Again, when you're done with this assignment, go back and work on anything else. This is worth double points and you get a tech token and you get extra credit. Like, there's all sorts of reasons to get it done today. And if you finished watching this video, then please respond to the post on Google Classroom with the word watermelon, and I will give you extra credit. Thanks for watching the whole video. Okay, bye.